Godot Game Engine is a completely free, as in freedom, game engine, which is one of the biggest differences from other engines, that it's totally yours when you get it. It's under MIT, you can use it for your hobby efforts or for your commercial games, and everything is yours. Also, what a huge benefit with that is that it's a community project, and for example, a nice example of that is that in other engines, if you have an issue and you don't have a huge amount of money, you can't pay the developers of the engine, you won't get the solution for your problem and you'll have to struggle and work around it. While in Godot, as in every game engine, there are issues, but the cool thing about that is that people actually listen and solve the problems. As an example, yesterday Mate submitted a bug issue, and there was quite a large discussion already on how to solve it, what are the workarounds, and when the solution could be implemented. While, for example, the engine that we have used a lot too, Unity, there I have seen that people have produced solution for a problem, suggested that for Unity technologies, and they have refused to accept the solution because it doesn't fit their license terms and the bug is there for years. So that is one huge benefit. Other benefit, what programmers are talking about, it's code synchronization. Bad code synchronization leads to bad state, and bad state leads to bad scaling, which means long-term projects are very difficult to implement and support in many applications, and Godot works around that in a beautiful way because the code execution order is implicit to node structure. But I guess that is too abstract what I'm telling right now when I'm starting to get in technical details. So let me open Godot. Let's get into Godot. You can download Godot from the Godot website. And there's a wonderful documentation there, which I'm going to probably explain a little bit more about that in a soon future. But the wonderful thing is that when you download Godot, it's just a little bit over 20 megabytes of size. If you download with a C# support, it's a little bit more. But the wonderful thing is this 20 plus megabyte download includes in itself everything. Editor, text editor, animation player, and editing tools, sprite styling tools, etc, etc. First thing you see when you open the editor is the project manager screen, where you can, for example, in our case I have few games here, but let's make a new project. I'm going to make it in projects Godot 3. We can choose now. The big feature in Godot 3.1 is OpenGL ES2 is back, so the older hardware is supported, and we can create a new project. Let's call it test. Create folder. If there is already one, let's create another one. Create a folder and create an edit. What you get is opening Godot editor itself, and in this case I'm going to go and do one thing that you cannot do in many other game engine editors, which is let's go and go to editor settings, and let's do display scaling, and let's make it 175%. Save, restart. And now when Godot restarts, we have a huge text, so you guys can easily see what's happening. What we are going to do, we are going to create a game. First thing that I'm going to tell you is that we are going to create 2D game. We haven't worked with Godot in 3D. One of the downfalls of Godot as of yet is that the rendering engine for 3D is not yet up there with the performance with Unity and Unreal, but that's not a huge problem because, as I said previously, Godot is being developed very rapidly, and new, very efficient Vulkan-based 3D renderer should come with the version 4, which is going to start to compete with Unity and Unreal in terms of performance. Let's go with 2D. And here we are going to create a 2D scene, which is just a node. Here in node 3, let's call it world. And let's save this. Let's create another scene, which we are going to call a user interface, which is control node, and which we are going to call GUI. Let's save that too. Let's create another scene, because the world in Godot is built out of scenes. And scenes are similar to game objects, but the similar technology as Unity have maybe got inspired by Godot is nested prefabs, what you could see in in Unity. In Godot it's called scenes, and it's an incredibly powerful structure. It works better than in any other engine, at least with the such a presentation, because it's there from the ground up, because the Godot editor itself is just a game built in Godot API. That's why it's super powerful. Therefore you can implement any technologies that you would connect to Godot in that moment. And the cool thing is that Godot includes support for many scripting languages, as it's just an API with the possibility to plug in anything, and you can build Godot in a one line, at least on Linux, a super short line with any updates you want. And so Godot includes a lot of cool stuff that I'm going to show you in a moment that you can attach to the nodes. One thing more that we are going to do, we are going to create another 2D scene, which is going to be node 2D. We are going to call it player. And let's make another one, which we are going to call spawner. We are going to create a game where you can move a little catch sprite on the bottom, and you catch items that fall from the top of the screen. So, and we are going to do it in a pretty simple way to not get into much detail, so that we can get into time bounds, and you guys don't get caught up in a too complex topics, because there are cool things that you could spawn items out of curves, and a lot of awesome tools are built into Godot. Let's do this now. Let's instance those other nodes that I just created in world node structure. Let's just do instance, and here I have a list. Let's do, at first let's instance most likely spawner. Then let's instance under the world player. Let's also instance under the world GUI. When that's done, let's go into GUI scene, which you can edit now separately. And let's create another child node, which we are going to call label, which is just a text label. Here we can type in score, which is there. Cool. Let's call it score label, and let's make another node which is actually going to be label for the score. When that's done, let's create a player which is going to be this same node 2D, which I'm going to manage, but let's add some kind of a indication that's there. Let's add a sprite. Let's add in the sprite for now just a default icon of PNG, which is a Godot logo. Save it. Spawner doesn't need any icons, but let's also make another scene which is going to be spawned item. And save the scene. Add another scene under that, which is sprite, and let's load there in also an icon of PNG. That's done. While I'm doing that, Mata is actually working on some visual items so that the game looks a little bit nicer when we are finishing up. In the world, now we have a GUI, spawner, player. Now, let's start. In Godot, you can attach only one behavior to one node, which is actually very powerful. In the first moment, if you have used Unity, it might seem weird, But when you invest yourself and understand how the node structure works, it actually follows very nicely the object-oriented design. And here we are going to create a script, and as I said, auto-completed, replace in multiple files, on the fly, error checking editor is open in itself, in the Godot itself. Let's create a variable that we are going to export, and that is going to be a packed scene. That is going to be a behavior of the spawned item. I should have done this for the spawner. So I'm going to create another script for the spawner, and I'm going to do it here. Export a variable, which is actually going to have a export type of packed scene. var. You can use multiple languages. As I previously showed when I was adding a script here, if we would remove script here and would add another script, you can for now choose native script, which is going to be, you can talk with external libraries which you can recompile. So if you need additional performance, you can add C++ or any language functionality to Godot and do it efficiently. You can use default GD script, or you can do visual scripting where you can just code using nodes. Also, if you download version with C# support, you can do C# coding, and there are support for other languages as well, like NIM, Lua and others. And you can basically use any C-based language through native and huge slew of languages very easily, or implement any language if you are ready to invest a little bit time, because it's open source project. So let's get back to that spawner, which we are going to call spawned item. And a new feature in the Godot 3.1 is that you can do type hinting. You don't have to put types for the objects that you are, for the variables that you are defining, but in this case I'm going to show off that you can actually do that. You can do this, and you have now we have a variable that is exported, and we can save it. And now if we click on the spawner node, we can see that there is a spawned item which is waiting for something to be attached. Let's go to the node tree here in the world. In a spawner, it's exposed here too. Let's load in, and let's load in spawned item scene. Done. We can save here spawned item. Let's go here. As you can see in the root here version, in the default version of the spawner, there is nothing attached, while in the instance there is spawned item attached to the spawner. So you can create amazing structures. Now when we have few nodes in the structure, I can talk about what I meant by implicit code execution order. Here in Unity, if you are building game, you can never tell how the code is going to execute, so the code can execute differently on one computer in a build or in the editor, or differently on two editors in the same project on two computers, which is a huge pain if you're developing larger projects. You can do that, you can solve that by creating master update functions, etc., etc., but all that is workarounds. Here, that is implicit. And so what you do is that you could move here, for example, this node over the spawner, and now player would execute before spawner, and spawner would execute after the player, the behavior of the script. So I'm going to put it back, and as an example, let's quickly create a example. Let's jump into spawner. Let's go into the script. Let's go to the ready function, which, if you are familiar with Unity, is basically a start function. And let's print out. Also wonderful that you can, in a print, you can put any type of variable, and you can combine them in any way. You don't have to worry about conversion. It's going to be done automatically, so it's very convenient to do debugging. Of course, there is also built-in debugger where you can step through in the editor, stop the code, execute do whatever you want. Let's output here message spawner, and let's actually go into the player and add a script to the player as well. And in the player script, let's add code. Let's add print message, which is going to print out player. Now, when we are going to execute our application for the first time, it's going to ask which scene to use as a default scene. Let's choose world. It's going to run the game, and as the game runs, you can see spawner, player in the console. Now, if we would do the same thing, but here we are just drag the the spawner under the player and would run the game again, we could see that now we have a player spawner. So the code execution is implicit to the node order, which is insanely powerful. So let's see. Let's save it. Now, let's get to sipping a little bit of beverage. And let's get to making game itself when we have gotten through the very, very basics of an introduction of the engine. I think that it should make a little bit clear statement of what we're doing here. Let's make so that spawner spawns some kind of items in the world. Let's go to the spawner script and let's go to the function process, which is basically analogous to the update function in the Unity, but here in Godot, as the execution order is implicit to the nodes, we don't need late updates and other workarounds and hacks to do the code. We just have a process and physics process, and that's it. Nicer, cleaner code because of wonderful node structure. So let's do the thing that is here. First thing that we should do is let's define a let's clean out these comments. The code, as you can see in GDScript, is very similar to Python. It even borrows standards from the Python, though it's not Python, because, for example, functions are not first class citizens for the performance reasons. So let's do this. Let's declare a variable. You could create a timer node here and use that to control timed events, but I'm going to do it manually through the code. That's just a preference of me, of being a coder for many years. So let's do spawn time left, which we are going to hint so that its type is float, which is going to be the variable. We can define a constant to avoid magic numbers, and let's do a spawn time. Let's define it to be, let's say, let's spawn item every second, and let's make initial value to be spawn time. What we are going to do now is we are going to have a function that is going to spawn the item, which we are going to call spawn item. And what we are going to do, we are going to take the spawned item. Actually, I should probably have called the variable in a different name. It's a little bit confusing, but it will suffice. Spawned item equals, let's see, let's call it current spawned item, and let's make it spawned item dot instance. Let's make a instance of that spawned item in the world. It's instanced, but it's not yet in a tree, in a world tree. So what we are going to do is we are going to make so that the object is going to live in the world. For example, in Unity you can deactivate objects and activate them. It's the same as in Godot, you would remove them from the tree or add them to the tree. So as of yet, the object is seemingly deactivated because it's not yet in the tree, it's not being managed, though it's in the memory. Let's do this. Let's make add child to this object, which is spawner, current spawned, current spawned. I'm usually using Emacs as my code editor, but here I wanted to show it as an example in Godot editor, so I got a little bit confused why don't I have auto-completion there. Add child, current spawned item for the current buffer. Current spawned item is going to be just going to be spawned, and now when we have a current spawned item, let's set its position, which is going to be local position, to vector 2, and it's going to be rand f. Well, also, one wonderful and powerful feature in Godot is that help is built in. You can search it quickly. So for example, if we would want to know what is the randomization functionality, I can just press F4, rand. Oh, here's randomize rand f. What is rand f? Returns a random floating point value between in the 0 to 1. Example 0, 3, 7, 5, 6, 7, 1. So let's use it. You can jump back to the code and let's do rand f. Let's multiply it by the how do we get the width of the screen? Size? What is the size? Interesting. What kind of a size we are interested in? Should we get world? What is this what we are working in? In Godot you are working in a viewport. So you can create as many viewports as you like, but by default you have a default viewport. So I'm going to make this task easier. It's a viewport. I'm checking viewport, and now if I'm going to check viewport, I can see there is a function get viewport. Okay, I can get viewport. That's viewport. What's viewport? What options viewport has? Size. Cool. I can use a size for the it's a vector 2 value. I can use a size. Let's use a size. Get viewport dot size dot x. Now we have that, and let's spawn the item at get viewport. Well, let's make it at the 0. It's going to be at the spawner position. Now it depends where the spawner is positioned. In the world we can see that the spawner is positioned here on top of the screen, so it's going to be here. And the value is going to be from here to here, the whole width of the viewport, where the item is going to be spawned. Let's run the game. Well, probably not as of yet, because you won't see anything. And let's spawn item here. Just do this, and we are going to spam spawning here, most likely. What have I missed here? It's going to be var. And we can, well, actually here, it would be a node 2D, what I'm spawning here in the world, but I'm going to leave it out, so you can see I don't necessarily have to provide the type for the variable here. Just as an example. Here, if we would run the game, then as you can see, the whole top of the screen is being spawned full of the spawned items. Let's improve the code. Let's now do this. If spawn time left is smaller than 0, is smaller than 0, then spawn the item and make spawn time left equal spawn time. That's done. Else spawn time left, remove delta. The difference between two frames, the difference between two frames is a delta argument which we can use. That means that independent of time we are going to decrease the time and in set intervals spawn the item, which in this case it's a 1 second. But I'm not going to get into details of programming that much because that's another topic, right? It's not really a Godot topic. So let's do this again. Let's run the game, let's debug, and we can see that now we have spawning in an intervals of 1 second. Cool. Now let's get to the object-oriented approach of Godot. We don't have to manage anything from spawner anymore. Let's get into spawned item, and now we have to have a script for it. Let's load in. It detected that there is already the script, and let's just do this. Let's remove the comments. I dislike them, and let's remove this also, and let's put in process function, and let's make the item to fall down. Let's make it position dot y plus let's define in this case just a constant which is going to be fall speed, and that's going to be, for example, 30 units. Let's add fall speed times delta, so that the object would fall with a set speed constantly. And let's follow the the idea that you should name your constants with the capital letters. Now, and also of course const should not be capital letters. So now if we would now, and let's also change this variable here. I'm not used to working with mouse, usually don't use mouse at all while doing my coding. So now we can see that the items are falling down. The speed most likely is too low, but we can see that we already have the behavior of items living in the world and falling. Let's increase that speed to, let's say, 300. Let's multiply it and let's have items falling from the sky. Now, when we have enemy behavior ready, let's work on the player. So here in the player, let's also remove the comments. Let's introduce the function, which is a process function, delta. And let's introduce the, let's make so that the player follows the mouse movement. So what do? We have to change the position dependent on mouse movement. So let's do that, but only on x axis. So let's do that. Player position equals, let's make a new vector 2, and let's here do just 0 local position in the world, while though most likely it would be nicer to have just position dot y, you know.
So I have first person in the chat. Hello from Vidzemes University.
Yo man, welcome. I'm going to answer to the questions in a short while as the game is going to work. Let's also then get the behavior. How do we work with the? How do we get the mouse position? Let's see. Mouse. Get mouse position right away here. How do I do it? Oh, it's vector 2. Get mouse position, and under what is it? It's under get world. Oh, it's under get viewport. So let's get back to the code. Let's again get viewport, and let's get mouse position. Oh, yes, cool. Now we can then do X, and now we should have a behavior where the player is going to follow mouse position, though it's going to be most likely now on top of the screen, but that we are going to change and improve in the design stage of the scene itself. Let's get into the game, and we can see that I can already move the player around on the screen. Insane! Cool! Now, then let's improve the design of the game. Let's go to the world here. Let's take player. And let's move player down here on the to the bottom of the screen, and let's make it to go in the middle of the screen, most likely, though it's not that relevant because it's going to be dependent on mouse position anyways. So let's get back to the game, and now we have a player on the bottom of the screen, and I would catch items. Amazing! Now only thing that is left in the game is to detect collisions and add score and restart perhaps the game. For the game restarting, I'm going to introduce you guys to a new concept of the game, that is signals, where you can signal one node to another node when something has happened in the world. So let's stop the game and let's do the first thing. Let's detect the collision of the player against the enemy. That is going to be the best to be detected, I think, in this short example, in the item itself that we are colliding with. So we are going to follow object-oriented design. We are not going to implement data-oriented design in this case. We are not going to iterate through the items. Let's leave that task to Godot, and it's going to happen automagically. So let's get to the spawn item. Let's get to its script, and let's make a new function, call it manage collision. Also guys, in this short example, as I'm going to get in the world, you could add here in the world, no problems, for example, various physics nodes. For example, area node, or you could add kinematic body 2D, or kinematic body in 3D, or you can do various physics implementations. That works well in Godot, and in 3.1 the physics are improved. Though in this short example I'm not going to get into that. I'm going to detect collisions very simply by checking the distance from the player to the spawned item. So let's get into the script again, and let's do manage collision. We have to get somehow access to the player. Let's do that. Let's get parent in the node tree. Parent is going to be spawner. I'm going to show you quickly the remote, as you can see while the game is running, what's happening there too. Now let's then get back to the code. In a moment I'm going to show you why I'm typing here get parent. Get parent, get parent. Now I got the top node world, and in the top node world we are going to look for node here, which is called player, and we are going to assign it to var player. In this case, let's hint the type. That type is going to be node 2D. Let's save it, and let's right away check for the collision. So for the collision, we should check for the distance from the spawned item to the player. Let's check distance. Do I have any distance or something? What I can check here? Get max distance, min distance, distance to something. Yeah, there is distance to. Vector 2. Vector 2 function distance 2. So returns the distance to vector b. So I have to just call distance 2 on vector 2 and provide it another vector, and it's going to return the distance to another vector. So let's do that. Let's do position of this node, distance 2. And as you can see, there's also distance squared 2. That is a neat trick. If you are building a larger game where you have to do a lot of distance calculations, I would suggest you to return square distance, because then you can avoid an expensive function that is square root calculation in each operation, and that can make a wonderful performance gains. That's just a programmer's tip. If you need relative relationships between the objects, not exact distance. But in this case, let's just make it easy and check the distance. Let's provide the player position. Okay, now let's check if this distance is smaller than, let's make here another constant. Let's call it collision distance, which is going to be, let's say, we could get the width of the object, but let's just manually calculate it. For example, if the distance is closer than, let's say 1 unit, or I don't know, like 10 units. Let's calculate it that way. Let's make it collision distance. Then let's at first debug it. Print M1. Do we detect the collision here? Let's run the game. Let's check. Here, item is falling. Uh-oh. We are not detecting the collision. So, something is not right. That thing that is not right, I have to use this manage collision in the process. We can add that. Now we can check again. Will we get the print 1? Let's run it again. And we are detecting the collision. That is awesome. While you could see that the collision detection is not precise, because as the object is still there, we can detect the collision multiple times. That is going to be solved by removing the object from the hierarchy and deleting it from the memory. Let's see. How are we going to do it? We are going to do it this way. We are going to type Q free. That means destroy object freely. In Unity you destroy it, you are a bad guy. In Godot you free the object. But you do it safely with Q. You can actually do it unsafely by freeing it immediately, but Q free is a nicer functionality. Now let's do this also. To do completely safe detection, let's make another variable and do it is collision detected. That's going to be bool variable false. Let's make it is collision detected equals true, and here this way we are going to both save performance and we are going to ensure that despite freeing being in the same frame or another frame, we are going to ensure that we are going to detect collision only once. So let's do this. Is collision detected? And we are going to do, if not is collision detected, and the distance is smaller, and let's increase actually the distance because we saw that it's quite close there. Let's make it 50 and let's delete it and let's run the game. Now we can see that as I'm colliding, I'm deleting the object and getting the collision only once. We can check it very quickly by printing out message that the collision is being detected only once.
To add to the challenge, you have around 10 more minutes.
M1, 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 M1. Awesome. So it's being detected correctly. Now, what we have left is collect points. So let's collect points in the game. At first, let's go to GUI and let's make so that the GUI fills the whole world. Yes. So let's go to GUI. We can see that it's already expanded through the whole level. We can do score and we can do anchoring where we want to put it on the screen. We are going to put it in the top left corner as it is. The score label, let's put it in the top corner and let's move it a little bit in, and the score, let's move it a little bit in the front of the score label. Let's save it. Also, let's go and let's make a little bit larger text here, the score label. You could load very easily fonts. Let's here you can load in any fonts in the and control them dynamically, and they are going to be generated on the fly to just that set of characters that you need. So that's insanely powerful. In this case, let's make text to look a little bit uglier, but let's just scale it. Let's make the scale of the object of the score to be, let's say, 5 and 5. Let's make it hilariously large, and let's move here the score as well, and let's make its scale also hilariously large, which is going to be 5 and 5. And we can test it out by putting some kind of a value there in too. Also, insanely, to just mention, very, very cool feature in Godot is that you can add let's jump quickly to spawner. You don't have to create, like in Unity, the classes with the specific definitions to export your data and to manage them. You can create export variable test equals some RI, and then if I would get into here, I could expand the variable of size, for example, 4, and add another RI as a, for example, child of that, and set that size of 5 items, and then each item there can be any kind of object, transform to D or another object, etc., etc., which is insanely powerful, that I have no time to and use to show off here, but it's insanely powerful feature in Godot that you don't see in many other tools. Let's get back to the GUI. When we have a node here, let's get back to the world. Let's see, score is there nicely in the world. Let's check so that it looks nicely there. It is. Everything is fine. Cool. So then one thing that we are left here, let's manage the GUI nodes structure here, the behavior here, and let's make the behavior add a script to the score. And let's delete the comments. And let's add a function here, process delta, and let's check get node, get parent, get parent, get node, player dot score. Let's make the text of this object to equal the label object. The score converted to string. Let's get back to the player. Let's introduce in the player script here variable that is going to be score, which is going to be 0. And here we are going to have in the spawned item, when the collision is detected, player dot score plus 1. So when that is done, we can get back to the game and let's see what's going to happen. If we are now getting collisions, we get the score increasing. Pretty cool stuff. Well, one thing that we can implement more is let's just show off signals, which is going to make score reset. The game state is going to reset to the beginning and you are going to play from the beginning. Let's go to GUI. Let's add another child node, which is going to be button. And let's make it the button to be in the center of the screen. Let's call it restart. And let's make it scale again larger, for example 5. Well, let's make it not 5, it's going to cover too much of the screen size. Screen real estate, let's make it to be centered. Cool. Now when we have a button, we can send signals to something, and let's go to the node pressed signal. We can check when the button is pressed. We can go to the we can add a script to the node itself. If the player, I could do that, I can send the signal to any object, to any other object. In this case, let's send it to node itself, to the button script, and let's send the signal, the button signal, to the button itself. And in that signal, let's just do get parent dot get parent again, get node GUI. Oh, and in this case you can see nice example. I don't have to actually get to get parents. I will get parent, which is GUI of this button node, and then when from the GUI we are going to get the node that is called here score. Let's reset its text to be 0, for example, string 0, and let's do that to the player as well. Let's do get parent, and in this case 2 levels up, get parent. Let's do a player node, and let's reset the score there to be 0. Actually, I would not need to reset here score because it's automatically being set always to the score. But in this case, I'm just showing the example of the structure management. Score is going to be 0. Let's run the game. And as I am getting the score, I can reset it to 0 here. And you may think, oh, why the button was not in the center of the screen? Well, because it was not positioned in the world scene. It was positioned there in the GUI scene here. GUI, we can set the rect size, which is going to be min size 1024 by 600, so it will take the whole world. And now we can see that the button is in the center of the world, and we can play the game full game. We can restart the game and do whatever we want. One thing I want to add at the end, why did I use those get parents and I was speaking about Q3, etc, etc. While the game is running, you can actually go to remote and view the whole code. So you can see the game is running here and go through the nodes. And here, from the button I got get parent, and got player. Get parent, got GUI and the score. Also, cool thing in Godot is that there's a JIT compilation. You can change the code while it's running. So that's insane, and the game is going to change the behavior, and it's insanely powerful. So for example, while the game is running, it's still running there. I have a score of 11. I could go here right now to, for example, player, and go to score, and you can see as it's changing in the dynamically. I could change it here by setting debug, sync scene changes, sync script changes. I could set it to 100, get back to the game, and then we can see that it's 100 here from inspector. Or we could go to the player script itself, which is here, local player, and we could set the score of the player, for example, to something different. For example, I don't know, score is 1000 here every time. And we can now see that in the game I introduced a new variable here and changed its value, and it updated in real time, and it's always being reset to 1000. Amazing, super powerful, as you can see. Now the last thing, we can import and export assets really easily by just dragging them in and out of the hierarchy. So what I'm going to do quickly, I'm going to get those assets that Mata is prepared. So let's just connect to his computer.
So I guess students could already start asking questions now.
Yeah. So 104. As I previously said, we haven't worked with 3D. We are waiting when it's going to become more mature, so I won't be able to answer any 3D related questions. Well, I can generally answer because we are building huge 3D game in Unity, but yeah.
Students typed disco. That's the first question. What disco does?
I'm going to do the dancing in a moment. Let me finish the game. So where did you put the assets?
And Trigen.
Trigen. And this only, right?
Yes.
So guys, actually, while I'm doing that, I'm going to show off another thing. I'm going to put in font as well in the game. So let's just quickly go to the hierarchy here in the game. Let's save the world. Let me finish, and then we are going to answer to the questions. You can write them down so that they are not lost. We can go to the scene structure. Here I can, for example, open show in file manager. We can go and open the folder, and I can just copy in assets from that folder, and we can see that they are automatically imported here with the previews nicely. Now, what assets where to put? Which are which? So player is which one?
Basket.
Basket is the player. So let's assign here basket. We can drag the basket in here, just like this. Boom. Or we can go to spawned item. Which is a spawned item? This falling item, right? So we are going to go to the spawned item, and we can click on the sprite and choose it to choose to load it, and which is going to be falling item. And let's also what kind of assets also you have. Let's also add a background. Let's add a new child node, which is going to be just a sprite. Let's drag it up in the hierarchy so that it's in the bottom of the items, and let's load in the background. So we now have a background, and let's just move it in the position where it should stay there. And do we have any other items?
No,
that's it.
Pretty much it.
And the restart button.
Restart, yeah.
You can we can go to the GUI. We can go to button, and we can just click so that it's not so that it's flat, and let's load in some kind of icon which is going to be restart, and now we have a huge restart button in the middle of the screen. Let's clear the text here, and let's maybe make the scale a little bit smaller. Let's make it, oh, and you can dynamically change the scale as well, as you can see, both in the world or here in the variables, so it's very, very convenient. Let's make it 0.5 and 0.5. And also, to show off the fonts, we can go to the score. Now we have font as well in the world. We can just go to custom fonts, new dynamic font, font, and let's choose the font that I just imported. This, we can see that the font for the score is nicely looking, and scale font, as you can see, looks a little bit ugly. We can go to the score label, change its scale to 1:1, go to the font, choose the new dynamic font. I could have assigned the same font for the both of them, but let's just for sake of showing off, let's do it here. Fonts, this one, and let's set the setting to, for example, be 70, and now you can see that it looks beautiful. We can run again the game, and we have a beautiful looking game.
Right, no one sees it because there's popcorn. Okay, now they see.
Amazing!
So, got already. Congratulations on making that game so quickly. So this one is easy. I can answer this. Can you name some of the most recognizable games made by Godot? The Ponye, right? The
Ponye ports for various platforms. Not all of the ports, but some of the ports. Yeah.
So what are the key reasons of moving from Unity to Godot?
Well, those are... let me just do one slight adjustment. I don't want this score to be reset constantly to 1000. I want it to be actually collected nicely. There are a huge amount of reasons why switching, but as I already said previously, the open source aspect of it, it's insanely powerful. Guys, it goes a long distance. Here in Godot, we are getting on equal grounds with the developers and other developers of the games. And so we can actually speak with other developers and actually work and compete with others. While in Unity, you are competing against people who are millions upon millions that they can invest in their game development. You have no chance. You have to be like a super YouTube star or something. You have to have social presence, huge social presence, to actually get somewhere. That is really one reason, but there are many reasons. Technically, I have a huge list why we prefer Unity, Godot over Unity. So, guys, you can always come to our streams. You are really welcome to come to our streams, and I'm going to explain to you many reasons why.
Okay.
But then again, you have to choose the tools for your needs. Unity is an amazing tool if you use it right. As I said previously, Unity 3D rendering pipeline right now is more powerful than Godot. So, Godot is the best for us, but Unity is an amazing tool if you use it rightly, and it has served us well.
Which is easier for a beginner to learn, Godot or Unity? How is Godot for mobile game development?
Well, I would say that Godot, in my experience, is really easy to learn. For example, there is a person, active person in our community, Jānis. He's not really a programmer, but he used another engine before that called Default. He learned Godot in 1 weekend. After 2 weeks, he was participating in Game Jam and made the game in 3 hours. Insane. I think it speaks something.
What's the thing you're missing from Unity?
As more I dive into Godot, as more I feel that getting back to Unity is a chore for me. I feel really as a chore to get in Unity, and I always wait for a moment when I'm going to get to Godot. Not really many things. Well, maybe the tool that I'm building, and I was in Brussels in the beginning in February, and I was presenting a tool that I'm working on, Visual Debugger. In Unity, Scene View is a pretty cool tool, and I'm building a tool in Godot that is a Visual Debugger that takes that tool that is Scene View in Unity up a notch. Because it actually gives you response of not a scene view, but actually the actual game running. You can actually modify actual running game in a game view as you would do in Unity in scene view. So that was one thing. And the wonderful, powerful feature of the Godot being open source, I can always look into the code of the Godot and communicate with the developers on equal grounds without paying them huge money and build such tools.
And here's a question that also can supplement the previous one. Can you build projects to as many systems as Unity? No, that is probably one thing that's missing.
No, let's export the game. That is also one place where Unity is more convenient for users, not because of technical superiority, but because of legal reasons. Unity Technologies over time has gotten a lot of contacts and a lot of financial support to implement legal terms with the many companies. But here, if I would go to export settings, that's why you can actually export on those platforms from Godot. In Godot Con, where I was in February, person was explaining how they actually exported Keen Dreams, which is actually another commercial game remake in the Godot on Nintendo Switch. While if you would go here in export settings, I would add Android, iOS, HTML5, macOS, Windows Universal, Windows Desktop, and Linux. From Unity, from Godot C# version, you cannot export on mobile platforms. But from default version you can export on these platforms. As you can see, Switch is not here, but from his experience, exporting on Switch was super easy. It was just building Godot with one new directory, and building Godot is putting in your terminal, if you're on Linux, this long line, like one command, which is very, very short, and it builds automatically.
Okay, so in my opinion, only plus for Godot is open source and free license. No.
Well, everyone is open to your opinion, man. Yeah, if you maybe you have more experience with Godot, but that is our experience, man. But if you also have questions about that, you can always come, and I have a huge list of amazingly powerful things why in the long years of working with Unity, developing one of the biggest games in Latvia, we have discovered the comparisons there.
Also, just from a designer's perspective, and just for someone who doesn't code, the engine is so small, I can just download and it's already executable. And
yes.
It contains itself, it just opens.
That is an amazingly powerful feature. If anything happens to your system, you can restore your system in a moment's notice. Godot installation, you don't have to install it. You download it, unpack it, and use it. You can use it from Flash. That is insanely more powerful than Unity. You can change the versions as you wish on a fly in few minutes. Your team can change and adapt to any situation. Another huge plus for Godot.
There's a question about no semicolons and no brackets.
Yeah, you can get them if you use C# version. That is just in GD script, that kind of behavior.
I already answered this. Do you call yourselves local Godot dealers?
Well, we do like Godot a lot, and Godot is not perfect. It's being rapidly developed, so there are issues. But the wonderful thing, as I said previously, Matejs yesterday submitted bug, and there was an active discussion with actual developers. And actually, when Matejs made the video, one of the developers, Matejs, was like hesitant to make the bug report, and one of the developers of Godot was like, "Did you already report your bug?" It's like, "Well, I have to report my bug." And then the developer was like, "Oh man, that was one of the best bug reports I have seen. Like, if everyone would do it like that." So it's amazing. That is a huge benefit.
Yeah, you're not dealing with business, you're dealing with community.
Yeah.
And when you're dealing with community, it's implicitly better service. You're dealing with people like you. When you're
Yeah.
dealing with business, like you have to deal it with like a business, and if
Yeah.
you're not
You
prepared
have
to do
money.
it, then you're on the wrong end.
Yep, and you should listen to this guy what he's telling because he has a financial degree.
Yeah. Any questions about the Godot engine?
Yeah, guys.
Any more questions, or are we out of time?
Yeah.
completely?
Also, sorry if it's like I'm dissing a little bit Unity. It's just my my feelings, honestly, in the situation where we are. But as I previously said, Unity, if you use it rightly, it's better in many things, right?
Can you use a sprite sheet in Godot? Yes.
Yeah, you can. And actually, it's improved in version 3.1. Not only that, you could go to AssetLib, another feature of Godot. AssetLib is for free. You don't have to pay for the assets. And there's a huge set of various cool plugins, and you can do direct import from tiled. Most popular tiling editor for the sprite sheet creation, you could create from tiled map importer for Godot 3, just drag in file and it's going to be automatically imported, and then you can draw your levels in Godot. Just take your mouse and draw them.
Okay. Sagristanos wants to party up in here, but there is actually a legit question from Comedy.
This is the time for me to answer to all of your questions. Guys, this is my time to see what Comedy Reflux is dropping down.
Yeah, and a question about Godot versus Unreal. All these engine questions come down to what you want to build. Like, that's where you have to start. What you want to build.
What is the question? Is there a way to... no. So... I will not go into deep detail of comparisons between Godot and Unreal because I lack the experience. I have used Unreal a little bit, going through a few tutorials, but I do not see myself in being in a position to compare them adequately. One thing I can say is that from my experience, Godot is much more easy to understand and use the concepts, plus the finding the help and integration and communication with people actually is wonderful. I went to Godot forums, thanked them for making such a wonderful Linux version of Unreal Engine, and I was answered by one of the developers of Unreal Engine, and they said, thank you, it's because of the community. So Unreal actually community is less poisonous than Unity is the worst community I have seen in forums. I have seen many people's when I ask like a complicated question, no one can answer. When I ask simple question, people I've seen developers like that Mike, or what is his name, who is very active, he was dissing beginners in Unity. Yeah.
Is there a way to free from memory all nodes that aren't connected to the main scene tree?
Yeah. Well, yeah, is there a way to free from memory all nodes that aren't connected to the main scene tree? Well, yeah, of course, queue free? I don't know.
Queue free.
Yeah. Well, you can do freeing.
Oh, okay, so they are wrapping it up on their end. Yeah, guys, we're gonna send you the project.
Yeah.
Hopefully today.
Yeah, and guys, if you have any questions, do come by. I did enjoy this little example. Hope you did too.
Yeah.
Was awesome talking with you. Come again, ask any questions. We'll be glad to answer. And yeah, we'll send you the project, and yeah, we'll be happy to engage